So hello guys, welcome. So today we'll be talking on equilibrium of forces. So equilibrium equilibrium of forces. So this should be just like a 30 minutes class. I don't want to take much of your time. So when we're talking about equilibrium, from the word equilibrium, from the term equilibrium, we're talking about something that is completely balanced. Something that what the total force or the net force acting on that object is what is equals to zero. Like when we say something is balanced, that means it is on a support, and that support is what is 50% on this side and is 50% on this side, which makes it balanced. So any net force that is acting on this object what is equals to zero. That means the net force acting on this what on this beam or anything is what equals to zero. Usually, if you're writing the exam, you get less theory on what on so that means the net force equals zero. So usually when you are asked questions, it's usually on um calculation. So we are going to be discussing the calculation part. I will give you a link to the theory aspect of this topic. But let's dive into the calculation part. So we have usually questions on beam, like beam, something that is probably that is linear like this, or couple. They should give you on couple, that means a round, and they give you two forces that are acting what that are acting perpendicular to one another. So these are mainly what equilibrium questions are usually on, at least for your level. But when you get to our institution, then you get introduced to a broader aspect, but it's usually on these two. So I think you have a scope of what equilibrium is. So let's look at some examples here. For example, now let's see this example one. This it says a body of mass 58 gram. So they say a body of mass 58 gram is suspended at the 28 centimeter mark. So of a uniform metal rule. There are some terminology should be meet in this topic. I want you to know them because you'll be applying them because they will keep showing up, so you need to know what they mean. So when they say something about uniform meter rule, just know that what it equals to 1 meter, which is equivalent to 100 centimeters. So 100 centimeters is equivalent to 1 meter. So I want you to put that in mind. When they say a uniform meter rule, that should pop directly right into your mind. So let's draw our meter rule. They say there's a meter rule. There's a meter rule. A body of mass 58 gram. A body of mass 58 gram. A body of mass is suspended at weight with 20 centimeter. So this place should be like somewhere around 20 centimeter. And what? Let's suspend our body of what? Our body of 58 grams. And the questions proceed by saying the meter rule is adjusted on a pivot until it settles horizontally at the 40 centimeter mark. That means this it pivots horizontally at what? At the 40 centimeter. So that means this distance between here to the pivot here will be what? 20 centimeters. So now they are saying what? Determine the mass of the meter rule. So you say we should determine the mass of the meter rule. So you should know that for the mass will be acting where at the center, which is what? Which is 50 centimeter, because that will be the middle. Do you get what I'm saying? The middle, the mass will act from the middle of the meter rule. So this will be what? The M. So because the mass will act directly from the middle of the meter rule. So and moment of a force, the same formula for moment of a force equals moment of a force. That will because what? The force times the magnitude of the force times what? That's the perpendicular distance. So perpendicular distance, when we are talking about perpendicular distance, that means what? It makes an angle of 90 degrees with that force. So you can see all these distances make what? The angle of 45 degrees, angle of 90 degrees rather, to this force. So but since they are saying we should calculate gram, we could have converted this into Newton because force is usually Newton. But since they are saying we should calculate mass here, so we might not need to calculate and just we might not need to calculate them in force and just do our sum straight. So then we should do, since since equilibrium moment of a force, we calculate the we know that sum of clockwise moment equals to the sum of anti-clockwise moment. So in this system, we know that the sum of anti-clockwise is equal to the sum of clockwise. Do you get? So let's calculate the sum of what? The sum of clockwise. That means when they say something is clockwise, that means it goes in the direction of a clock. You know the hand of a clock. It usually goes like this. To go like this, it will keep going like this. To go like this. But when it's going in this way, that means it is anti-clockwise. So clockwise, let's go in this direction. So we have m, our force, m, moment F, m times what? Times perpendicular distance. So we are taking moment about this pivot, and the distance between this force acting downward and this pivot is what? Is 10 centimeter. That equals 58 what? 58 times what? Times 20 centimeter. So we are just seeing the moment. So let's say we have another force here. Let's say we have 10 here too. We say plus 10 times what? 10 times, let's say this place is just 15 centimeters. That will be 15 plus 20, 10 times 35. So now you are submitting everything. You are calculating. No, this for this for anti-clockwise. So it will be on this side. Plus 10 times what? 35. The b. So let's say we have 10 gram here and you have 15 here. So it will be the distance of this to this place. So you understand? So, and if there are more forces, you do the same thing, because like we said, summation is just like addition of all the forces combined. So we are calculating the addition of all the moments and we are equating it together. That means both of them are equal. So let's disregard this and let's continue. Say 10m equals what? 58 times 20. Let me press my calculator. 58 times 20 to give 1160. 1160. So m now equals 1160 over 10. So that's 116 gram. So that's the mass of your meter. So 116 gram. So moving on without wasting time. So how about the case that this this what this distance we are talking about is not inclined to what? Is not inclined to horizontal. That's when we have to what? We have to resolve. So when they say it is not inclined to horizontal, you don't need to stress yourself. When you say anything like this, just do what? Just take this the magnitude of the resultant vector they give you, write it and put cos theta. That's if it goes upward. But if it comes down like this, just write 12 sine theta. It will always give you your theta. They will always give you your theta here. So theta is either it comes like this and you write your theta. So that's just it. So for example, now this one was 12 cos theta. So that is 12 cos 30 degrees. And cos 30 is what? Cos 30 is root 3 over 2. So that's root 12 root 3 over 2. That's 6 root 3. So that's just it. You can see 6. You can see what it is. 6 root 3. So without wasting much of our time, let's check this example 4. Example 4. So questions of moment can come in any form, any angle. Don't be stressed out. They are all the same thing. Just understand the question, digest it, and give them the answer. So this one here says what? It says a uniform bar long, a uniform bar 50 meter long. So just draw your bar, draw it as first. A uniform bar 50 meter long is what? It's balanced on a is balanced on a pivot placed at its midpoint. They said at its midpoint, that's at the center. You understand? So if you know that everything here is what? 15 centimeter, or what? 15 meter rather, and here to the midpoint is what? Is 7.5 meter, and here to here is what? 7.5 meter. It's balanced at the midpoint. That means balanced at center. They now said a body of mass 55 kg sits on one arm of the bar. A body of mass sits on one arm of the bar at a 0.5 meter away from pivot. That means from this place to probably this side or this side, but 5 meter away. You start from this way and move away. Let's move to this side. Let's say this side. A boy sits here 5 meter and it's what is 55 kg. Then I say what mass can be placed 2 meter away. Now say from this place, so 2 meter away from the what from the other end. You take this end, then move 2 meter away. Then I say what mass should we place here so that to keep this bar horizontally balanced. So the main distance here will be what 7.5 minus that's 5.5, and that of here will be 7.5 minus 5, that is 2.5 meter. So that's just it. You see that we've analyzed the question. So we just proceed by saying sum of anti-clockwise equals sum of clockwise moment. So and you know that moment of a force equals what? Force times what? Times distance, perpendicular distance. Put it in your mind. So this one is not a force, but since we are working with mass and mass, so we don't need to convert it to force as we still divide. So we don't need to convert to force, but you can. But when they are saying weight, you have no. Let me just convert. So when they are saying here now, they said force times perpendicular. So we need to calculate the moment of what? The anti-clockwise and the clockwise. So what? So moment. Let's calculate the first moment. That's 55 times 10. You know, mass times gravity. Gravity is 10. Will give us our force. And what's the distance? This distance from here to the pivot. This is where we are taking our moment about. So that will be 5 equals what? Clockwise is going like this. Our mass is m. The mg gravitation is 10. Gravity is 10 times what? 5.5. So that's just it. So we have what's here? 550 times 5 equals what? 55 m. So we say 550 times 10, 5 times 0, 0, 5 times 5, 25, 5 times 5, 25, so 2750 equals what? 55 m. So now m now equals what? M equals what? 2750 all over 55. So let me press my calculator. Let me see what this gives me. 2750 divided by 55. So that should give me what? So this is what? 50 kg. Automatically you get 50 kg as your answer. That means 50 kg must be placed there so that this bar can balance horizontally. So let's look for some questions on couple. So that like, oh, you did not introduce me to couple. I find in my exam, you did not introduce me to couple. Okay. So look at number 20 and number 21. That's what a couple looks like. It's just like moment. But in couple, you only pick one force and the distance. So for example, if they say calculate the magnitude of the couple or the moment, so you just say m equals what? 0.4 times the distance times force okay, force is 4 times 0.4, so that should give you 1.6, right? 1 point no yes 1.6, yes, and the unit is what? Newton meter. So you can see the answer here to 1.6. Same thing here, you pick one of the forces and the distance. M equals 10 times 0.25, which equals what? 2.5 Newton meters. So that's the answer. So 2.5 Newton meters. So that's the answer. That's just some couple. So if you have any question on moments down, especially on equilibrium of forces, because there are still some advanced questions on equilibrium of forces where you have to use the triangular vector, the and all the likes. Just put them, we'll solve it. Put them, but I just want this to be like an introductory part to the topic. Okay.